Hello everyone, welcome back to the WeeW electronics within the STM32F1 tutorial, and today's video is the follow-up for the UART tutorial. So during the last tutorial we have been doing the basics of the UART. So we initialized the UART peripheral, and then we had the receive and transmit function. So let me go back quickly to the program. So I started from the previous program, we made it, but today we will create a init function that will be a general init function where we have to choose the which UART we want to activate and also the baud rate. Great. So to start with the function, so we would like to have, so now this is what we wrote last time, but what we would like to have is kind of let's say void, so we don't have any output from it, and let's call it UART init. And we would like to specify like which UART is it. So I'll put inside unsigned short, because 1, 2, 3 we call it UART or USART, and also I have to input my baud rate, and the baud rate can be sometimes very fast. So I will use an unsigned long, and I will call it a baud rate. Okay, so that will be my my input. Great. So now that we prepared our function, we have to define some details about it. The first one is to understand the clock speed. So let's go to the UART again. So let's go to the reference manual. Okay, not the reference, only the datasheet. And that's a perfect. So we need to see here, as you can see, UART1 is connected to APB2. However, UART2 and UART3 are connected to APB1. And why I've been focusing on this, because we have a maximum speed for each one of them, and we need to be clear about the speed so we can define the right clock speeds. And to work with this one, let me use the STM32MX graphic, so that will quite be more visual. And we are using the STM32F103C8. Great, perfect, good. So first let me activate in this program, let me activate the high-speed clock and put 72 as it was set up. Okay, good. So the general setup for this one, so we see here for the APB1 peripherals, beside the timer we have a 36 megahertz distributed. On the other hand, for the APB2 we have a 72 megahertz. So to quickly start here, I will say if I am using, so I'll put it as a comment, if using USART1 clock speed is 72 megahertz. HT 72, not 73. Else that will be 36 megahertz. So, and this is based on, so if I save and go to I'm actually right now on, let me go to the simulator mode, and if I go to simulator and run my program, go to the reset and clock control, take a look, we have our H clock, which is the one we are looking for. Let me put both windows. Hope we are using a big screen so you can see what exactly the details. Sorry, that is a little bit small. And you can see the H clock here. The H clock is 72 megahertz. Okay, and so PC clock 1 is 36. PC clock 2 is 72 megahertz. Hope that this graphic will help to understand better how the clock is distributed through the buses in the microcontroller. Great. So now we know our clock speed. The next step is to understand our pins, which UART, as we said. So let's go back again. Yeah, here. So which UART is used for which function. So what we will go again to the reference manual. So it's something we went through during our last video also, but this time we will check for all the others. So we have the pinout description, and here we are. Okay, so let's take the UART one first. Yeah, so we have UART3. Okay, as you remember, we always have UART3 on 10, so that the transmitter is on 10. Immediately the receiver will be on 11. So let's note it in the here in the program. So for UART3 or USART3, so we said PB10 for TX and PB11 for receiving RX. Okay, so let's go back again. So yeah, PB10 and 11. I hope I didn't skip anyone. Oh, we have UART2. Yeah, USART2. Okay, so this is something we already went through during the last video, but quite worth written it just in case to avoid any mistake. So let's do this, and then let's write. So the UART2 is PA2 for TX and PA3 for the RX. PA3 for the RX, and let's check the PA1, the USART1, sorry, USART1. Let's go here. Where are you? USART1. So just let's just copy paste and look for it. Control F. Yeah, USART1 TX. Good. So it's a PA9 and PA10. Fantastic. So PA9 and PA10 for the RX. Okay, great. That's fantastic. So now we do know our clock speed, and we know which pin is assigned to which UART. Quite easy till now. So let's go now and start putting our code. So we bring this what we wrote here, and we just put it here because this is already the input for UART2. So what we can do, so if UART is equal, and we will put equal 1, and then we have some code, right, and then else if, and we write again our code. So this one, the else if is USART equal to, sorry, 2, and the last one USART, oh sorry, yeah, too many mistakes during writing this library. Good. Okay, let's put then all the code here. This is the USART2, and we put it here exactly. This is not an equal, and the last one, this is also not an equal. Okay, let's apply. So for this one, it's, yeah, the first also step, the RCC, this one where we enable the alternate function. This is something general, so we don't need to put it here, but we just write it here. So we are enabling our okay, just a moment, we enable the alternate function, so that's something for all the pins. And after that, let's go to this one. So what we have to change here, so this is UART2. I'll be removing all the comment here because we don't need, anymore, so we try it for 1. Yep, I will keep this setup just for understanding purposes. Okay, and what I have to do now is just using, instead of 1 I put 3. So here this is 1 1 1 1, and to enable the UART1 we have to go not to APB1 enable but APB2, as we have seen. And let's look for which. So let's go, yeah, reset clock, yeah, APB1 enable, and where are you? Yeah, so it's in the 3rd byte, 2nd bit. Good. No, sorry, this is APB2, APB1. This is APB1. We need to go APB. Yeah, then UART is the 2nd byte, and the almost the last bit. Okay, perfect. So to put it, then we go back here. So it's not this number, but we put here, here, and 4. So that's the 2nd byte, and before last bit. Yeah, perfect. And we said that for UART1 we have a PA9 as the transmitter and PA10 as the receiver, and we put it 1 everywhere. Okay, we do have a mistake here. Yeah, of course this one is wrong, but yeah, perfect. Okay, so let's, okay, this one looks fair enough. Let's copy this here and let's delete all this because we don't need it anymore. Okay, and so if our UART is equal to 3, let's put something here and try to set up. So for this one it's APB1, and I guess it will be the next bit of this, so quite direct forward, but just let's check. So if this is 2, then we have to put here 4, but let's have the, let's take a look. Yeah, 2, UART 3, then 4, perfect. And so we said here it's PB10 and PB11, so here PB10, so it's quite really straightforward, no need to even think too much about it. Okay, and here UART3, 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 and UART3. If I didn't forget, just to check. Yeah, great. So but now we inputted the baud rate, and we have to calculate each time the baud rate, as I have shown you last time. So I made a small file to show the baud rate, and this is how the baud rate is calculated. So this is based on the calculation in the reference manual, and if you do change the baud rate here in this file, you can see what number you have to input here. So as I changed to 128,000, you see that the baud rate now, the hexadecimal number, become 119. So even you change this one, and you see a small error. I will go to explain about this one when we will go to the reference manual, but you can see the baud rate is based on the calculation of the clock speed, and the input on the baud rate register. Okay, let's go to the baud rate and take a look to the baud rate register. Good, let's first go to the USART registers, and this is the baud rate register. Okay, so we do have two parts of the baud rate register. The first one is the fraction, and the second one is the mantissa. Let's keep this information in mind to understand why we do have these two parts. So, and to understand it, we have to go back to the main explanation place and take a look here. there is some details about the baud rate. Yep, and this is the fraction baud rate generation. So the baud rate that we are inputting in the file is in the register is this formula. So we need to have the clock and also the desired baud rate. Also, to input the data, so this is some examples to show you what kind of how we will input the data in the baud rate register. So we do have example 1. I think example 2 is the best. So if we do have like the baud rate is 25.62, we multiply the 0.62 by 16, we have 9.92, and then the nearest number is 10, so this is A. So what we do, we convert this 25 to hexadecimal, which give us some I think 19, and then we add the A, so the final number should be 19A for the baud rate register. Great, so let's go and start calculating the register. So the first step, so here I should input for the baud rate register here. So what I would like to use is, let's have a number here. We call it the let's call this number baud rate register. For let's before this go here and put a number called unsigned. Let's put unsigned long. Unsigned long, and we called the baud rate register calculation. Okay, good. So and this one will be equal, so the baud rate register calculation will be equal to the function called, let's call it UART baud rate, sorry, USART BR, where we have to input the USART, so we will know if we have 72 megahertz or 62 megahertz clock speed, and also the desired baud rate we need. Good. And here we will put, instead of this number, the baud rate calculation. Okay, so let's put this one here and here too, and here too. Okay, so the number is put. So now we need to create and make this function. USART, no, or something wrong happened. BRR like this. Okay, this is, yeah, this is not declared function, which is totally normal. So let's go here. Yeah, let's go here and add the new function. So this is like the output of this function. As we said, it's unsigned long, and let's put here, and it's exactly the same thing. So we have to input both information here. Okay, good. And let's start our calculation. So the first one, we need to confirm if the so we have to, yeah, let's, so the first thing, let's create some variable to get the rest of the division. I will have an unsigned long again, and I'll call it div, and this one will give us the integer number from the division by the clock. So this one will be equal 36 million, so 3 zeros and 3 zeros, perfect. Okay, and I put here. So after that I will create it, I need another variable for the fractional, so it will be a double, and I will call it a frac, and will be equal to also 36 million, and as it is I will add 2 zeros. Okay, and so if we have if UART is equal to 1, I will change these numbers. So I put the same number here, and I will use, instead of 36 will be 72, and also here 72. Fantastic. So now we prepared the fractional and the integer part of our baud rate. So yeah, let's declare it on the top just to avoid this red. Okay, after the library, let's put here. Yeah, looks fine. Wonderful. Okay, so first the div will be equal a div, so the clock speed divided by the desired baud rate multiplied by 16. So before, so just to get back to you and you don't get lost on this calculation, this is where the calculation is coming. So that's why I divide by 16 multiplied by the required baud rate. And this will give us the integer number of the division. And the next one will be the frac, which is also equal the frac divided by same calculation actually. So will be frac equal here frac again divided by yeah, BR. Okay, wonderful. So the next step is to get only the fractional part and multiply it by 16 to get this number, the same as the example here. So I'm getting the fractional, example 2, I'm getting the fractional and I multiply by 16. Actually, we can directly put it here. So frac, just do 16 and minus the div. Okay, so we do have the fractional immediately. Okay, so now that we have this fractional part, let's go to the get another variable. We call it decimal, which will be only the part of, like, it will be also, let's put the decimal unsigned long decimal. Okay, good. So as we multiply the frac by the decimal, so decimal will be equal to a frac. So now we get only the decimal, the integer part of the frac. The frac is a double, and we go through another frac just to confirm what's happening and what we put. So we need another double here. I will call it frac 2, and I put, it will be, yeah, just 1.00. Okay, and frac 2 will be equal, no, it's frac 2 will be equal to 100 multiplied by frac minus decimal. So here what I'm taking only the remaining part of frac minus decimal, and this one I'm putting in frac 2, and this is to confirm the number that we will have for the fractional part. So if here, if frac 2 is greater than 50, this means two things. So we need to increase decimal by plus plus, and if the decimal itself, so we do that because to understand if it's the biggest part of the number. And also if I go in the, in example 3, if you have a 99 and it gives you like the total 84, for example 99, you have to jump. So the biggest number is 016, so you have to jump to the next number. Okay, So, and if the decimal is equal to 16, then what we have to do is to put the decimal at 0, decimal equal 0, and go to the div and put increase by 1. Okay, I hope there's no mistake here. Okay, perfect. So finally we have to put both parts, so I will call another unsigned long, I called final. Okay, yeah, nice name. So final will be first equal the div, but moved by 4 digits, and then final will be plus equal to dec. Okay, and we return final. Okay, that will be the final number we will be returning. So what we have done at the first place is to calculate. Let's divide the screen and have a view for both the tutorial and the example, just to like this. Okay, yeah, it was quite straightforward, but just to explain again, the first part we have done is I took here, so this one is to take only the 25. So now we know that we have the 25. Next, I took the fractional. So the fractional was to take 25.62, which is a fractional divided by this. And after that, just to confirm, yeah, that's wrong, yeah. This one, and then I need to add, so fractional divided, this is something here, so I need to add here. Perfect. It's always good to double check again. So I put 25.6 minus 25, and I multiply by 16, and I got this number, or like whatever the example. And after that, I took the decimal number of this one, and I put this number 9.92 minus 9 to get, and I multiply by 100, and it gave me something between 0 and 100 in the frac2. And I checked if the frac2 is more than 50, so here, so the nearest number is the next one, so I take the decimal, which is 9, and I add plus 1. So here, so if it's greater, it's plus 1. And if the decimal is equal to 15 and I have to add plus 1, it becomes 16, which is an overflow. So I need to put it, if it's 16, I need to put the decimal to 0 and add 1 to the 25. And then I do, as my final is composed of the division 1, so I have to move it by, so let's go back to the register, the baud rate register here. So I have to put the division on from the 4-bit number 4. So I moved the division by 4 bits, and after that I just added the decimal. Okay, I hope that this explanation was useful. Okay, so now we do have the whole function ready. So the library is here, and let's check. So I need to copy paste this one, and let me remove all this because we don't need it. We just have this wonderful function. No, before that I have to put it here and here, and I will put here the number, for example 2, and the baud rate we used previously was 9600, just to see if this is working. Okay, great. So it seems something is wrong here. 2 expected, something is missing. Yeah, of course, the void is an extra here, we don't need. Okay, great. So let's save and check if there's no issue. Okay, 2 warning, of course. Okay, so let's check what warning. Frag never. Okay, div was declared but never referenced. Which div and frag? Okay, reference. That's new. Okay, just to confirm, seems to be fine. Let's put here UL just to avoid UL. Okay, the warning kept there, was declared by never referenced. Okay, I will check later on about this, and but let's take a look on the simulator, and let's run. So we go to peripherals, UART, UART2. Okay, so you can see here, that's fantastic. We have a clock enabled and 9600 baud rate, so that's fantastic. Let's try another baud rate. So let's close the simulator and check whatever the baud rate. Let's choose from the H term, whatever the baud rate. Let's choose 1000, this one, 11,000, 115,200. 11520. Okay, let's save, run, and see what's happening. Okay, run it and go here, extend UART, UART2. Okay, that's interesting. So you see here that it's not exactly the same baud rate, and this is what I added previously in this error. So as we do have only only 4 bits to input the digit for the baud rate division, there is a small error happening each time. And if I put here again the 11,000 here, we do have a 16% error happening. So that should be normal, but let's make a test, a real test with. Okay, so we still have the same code for the send and receive, this one. So let me create a UART lib. Add, so see UART lib. Okay, or UART drive to keep consistency. Okay, and also the H1. Header, UART, yeah, and a drive. Okay, perfect. So let's put all this here to remove all the condensation. Control X and put a text. Okay, so I'm removing, that's not the file that I'm intending to add. That's the header file, UART drive here, and let me add these 2 functions, Control X here, and we have to include UART drive.h here, and including it also in. So I close this one. We have to include it here too. Okay, should be cleaning everything. Yeah, of course, I need to include this one here. It should be closing everything we do have. Yeah, we need also to add the GB drive. Yeah, that function is so helpful. Okay, let's check. Okay, wonderful. So now we have much less much less gathered data, so it's quite easy. Okay, let's save. Okay, I know here it's quite easy one. Just put one here and add one here. Save everything and check. Okay, 2 warnings, we know them. Okay, so now we downloaded the data in our code, so we do have now all the information. So let's go to HTML and connect with a baud rate of 115,200 and say hello. Check if the code, it's working. Wonderful. So we have chosen now, so just to show you, yeah, it's already connected now UART2, and let's change the UART. So if I change the UART, I have to change also the setup here, but worth it to check. So let's put UART1, and so here UART1, UART1, UART1. We will create the library for the next video. So okay, let's check. Okay, so let's go to the debug mode and check how things are going so far. Okay, so what we see here is we do have the wrong baud rate for the UART1, so it's enabled but wrong baud rate, so probably something wrong happening. Let's go to the C here, the UART drive, and we still have this 2 warning, and okay, that's the warning here. I declared the variable twice. Okay, and also, yeah, I'm putting a really nice number here, so just let me copy this number and put this number here. Okay, so let's save. Yeah, we don't have the warning and any other message now, so let's take a look and check how things are going. Okay, fantastic. We do have now the UART1 enabled and the baud rate is correct. So let's make a last test for the UART3. Yeah, quite a lot of fun. So we do have a function that immediately calculates the UART that we need. Let's take any other. Yeah, let's take a 256,000 baud rate. 256,000 baud rate. Okay, so let's save and use for UART3, build and take a look. Okay, so we don't need UART3, but we would like to see the UART, no, not UART1, but UART3. Let's run and see. Okay, so we do have a 25,000. Yeah, that's a good baud rate and it's enabled. So let's make a test for the UART because we connected on UART2, but let's change it. And so let's change again UART2 here. And yeah, we have to leave the debug mode. Okay, and let's load it in the microcontroller. Okay, so let's load it in the microcontroller. So okay, should be loaded and fine. And let's discuss with the microcontroller using this one. Let me clear here and put the famous hello world UART. Yeah, okay. RT. Okay, it didn't send. Something is wrong. Tell me what. I put the wrong baud rate, of course. So let me copy this again. Control Y. Okay, copy. No, I'll write it. Hello world. Okay, of course, it's obvious. We're not using any more UART2, but UART1, but you have to put UART2 here everywhere. So here we have the receive and send function. We will go through them for the next video, but now let's save and upload. Okay, build and upload again and try the hello world. Hello world. yeah, finally working. And let's make a long, very long text just to test again. Yeah, perfect. So we do have working text, and the init function is working for all the UART. So now we finish within this video all the updates for the UART. So we do have a very simple function where we put which peripheral UART we would like to choose, and also we calculate the baud rate. In the next video we will be looking in details for the receive and transmit function, so we can have a very easy and easy to use function for all the UART testing. Thank you a lot. If you like this video, please subscribe and give us a hands up. Thanks. Bye.